Welcome students. Today we are going to discuss another topic from chapter 2, the computer system. From this chapter already quite many topics and subtopics we have already completed, and today we are going to discuss with some other topics. Before we proceeding to the topics, let us see the previous topic which we already discussed in the previous classes. Characteristics of a computer already we have completed. Strengths and limitations we have completed. Basic applications of a computer, the computer system, hardware we have completed. Under hardware, input unit. So under hardware input unit, keyboard, mouse, light pen, joystick, graphics, tablet, scanner, digital camera, MICR. MICR full form, do you remember? Magnetic ink character reader, which is called an OCR, optical character reader, OMR, optical mark reader, barcode reader, touch screen, microphone. All these topics which we have already completed. These keyboards, mouse, light pen, joystick, etc. are under the topic input unit. All these are input units. Already have completed this thing. So today's topic is central processing unit, RAM, ROM, secondary memory. RAM full form is random access memory, ROM is read-only memory. Secondary memory, under secondary memory, magnetic media is there, optical media is there, flash drive, memory stick, smart cards, cache memory. All these topics in today's video we are going to learn. So let us start the class. Central processing unit. The central processing unit is the brain of any computer system. It consists of a processing unit and a storage unit. So central processing unit is what? Actually it is the brain of a computer system. No? So the central processing unit is actually the brain of the computer system. Or in short it is called CPU, which is look like it. Already you know what is CPU. No? This is the CPU. This is called the brain of the computer. Okay. So processing unit, it consists of the following things. Which is the things? Let us see. Arithmetic and logic unit, which in short it is called ALU. All calculations and comparisons, arithmetic and logic unit. Processing unit, that means central processing unit, it consists of the following: arithmetic and logic unit, ALU. All calculations and comparisons are made in this unit. The ALU performs the arithmetic plus, minus, asterisk, slash, and logical less than, greater than, equal to, less than or equal to, greater than or equal to, not equal to. This sign is called not equal to. Which sign? This is the sign. It's called not equal to. Okay, not equal to operations. So arithmetic units is using these following arithmetic and logical operations. And control unit, arithmetic unit, all calculations and comparisons are made in this unit, and arithmetic and logical unit will perform the arithmetic and logical operations. So control unit next is, the control unit controls the flow of data from input devices to memory and from memory to output device. Control unit what will do? When you give any input to the computer, that time it will accept it as the input, and after that it will give an output to the output devices. Okay, and it does not process the data, but rather acts like our central nervous system. So control unit it does not process your data, whatever data will enter it or the input you will give, but rather than what acts like the central nervous system, no, it will work. So input it will collect, and after that output will give. Right. So when the processing begins, the first program instruction is selected and fed into the control section from the primary storage area. It is then interpreted there, and the signals are sent to the other components to perform the necessary action. Then the next program instruction is selected, interpreted, and executed. This goes on until all the instructions are processed. So this control processing units is collecting, and then after that we will give the output, and that all process with the arithmetic and logical unit. Next is registers. These are high-speed temporary storage area found in most modern CPUs. Registers work under the directions of the control unit, storing instructions and data immediately required for performing an operation. Registers, what will do is that these are high-speed temporary storage areas is there found in the modern CPUs. Central processing unit. Registers works under the direction of the control unit. Forward purpose, storing instruction will store and data immediately required for performing an operation. So it will store the instructions, after that immediately going to the instruction, no, immediately the required performing will do by the registers. This part, how it is work, these parts are connected to the rest of the computers through how? Buses. What is this buses? Buses, wires or circuitry carrying electrical signals. That means with the help of wires or the circuitry carrying electrical signals, no, most computers have three main buses. So buses, through the buses. What is this? Most computers are having the three main buses. These parts are connected, as you say, to the rest of the computer through buses, and three main buses are there. The first is data bus. It carries data from memory to the CPU and from the CPU to the memory. Address bus, it carries addresses, specific places in the memory where data or instruction may be found or stored from the CPU to the memory. Now last is control bus. It carries instruction between the CPU and the other parts of the computer. It means these buses are helping. No? It carries the data. The first is data. Whatever input you will give, no, that data will carries from the memory to the CPU first, then from the CPU to the memory. And address what will do? It carries the at a specific place where the data is there. No? Instruction may be found or stored. No? Where it is stored, from there to pick up, no, that address bus will work. Then control bus, it carries instruction between CPU and the other person. This control bus will help you to receive the instruction from the CPU to the other parts of the computer. Now that instruction. So data bus will carry the data from CPU memory to CPU, CPU to memory. Address bus will pick up those data from the specific place of the memory where it is stored. Control bus will give the instruction between CPU and the other part of the computer. Next is storage unit. From the storage unit, it consists of the following components. What is that? Primary storage. First is primary storage. The storage unit is in the computer that memory, RAM is also the primary memory it is called, and hard disk is also memory. No? It's a storage unit where you can store the data, hard disk. No? Before storing in the hard disk, first of all, it is going and storing in the primary memory, which is RAM. So storage unit is consisted of the following components, which are the one primary storage and secondary storage. From there, we are going to learn primary storage today. Now, it consists of the following component. What is that? Primary storage. Not as primary storage. Primary storage. The primary storage, also called the primary memory, serves the following purposes. These following purposes, the primary storage is working. What is that? Which is called RAM. Primary storage, not RAM. It is only memory, random access memory. as an input storage area where data is fed and held until ready to be accessed. Input storage area where the data is fed and the data which one where it is there held until ready to be accessed. That means until it is not ready to access and display on your computer. For that purpose, this primary memory first open, collect it, then it is sent to the secondary memory where your data has stored to access it. As a working storage space used to hold the data that is being processed and the intermediate results of such processing. So, work storage space used for what? To hold the data. For what purpose? To process, to process your data and give the output on the screen. As an output storage area to hold the final result of the processing. As a program storage area to hold the processing instruction. So, these following things, components are using the primary storage. So, before proceeding to the next one, we will see these following components, how it has works. The separate areas you do not have built-in physical boundaries. They can vary from one application to another. A computer can store vast amount of information and can recall the information instantly and correctly whenever desired. Whenever you need that time, the computers can give the information instantly and correctly whenever it is required. How it is? And already you know that the information in a computer is stored in the form of what? Strings, which is the binary code. What is that? Already I have discussed in the classes. Zeros and ones. Zeros and ones in the binary code. With this only bits are grouped together to form larger values. Then with the 0 and 1, that is bits. And all these bits are now grouped together to larger values. Then after that, from the bits, from the base unit will be increased by each bits from 1 byte, and each byte represents a character that is a, etc. like that. And combination of 4 bits. Combination of 4 bits is called nibble. That means 0 and 1s. With these, the first one is bits. After the bits, then when it will be grouped together, it will become larger. Then from the bits, it will be converted to what? Bytes. Next is bytes. Then from the bytes, it has 8 bits. 1 byte equal to 8 bits. Okay, with 8 bits, 1 byte it is called, and 2 byte is 16 bits. Like that, it has increases. According to that, we are going to know how we can calculate it. So, 1 bit, when your data are more, when your data are more, then all these bits are grouped together from a larger value. So, what is this larger value? Then it will be increased from bits to byte, and 1 byte equal to 8 bits, as I have told. So, 1 byte is the smallest unit that can represent a data item or a character. Other units of memory are listed below. So, here you can see that 1 byte is the smallest unit that can represent a data item or character. Okay, and when your data are more or larger in size, then it will be converted to others. So, that is from bit to byte, from byte to kilobyte. So, 1 kilobyte, 1 KB, which is called KB, KB means kilobyte, means to the power 10 bytes, that is 1024 bytes. Okay, then 1 megabyte, 1 MB means to the power 10 KB, that is 1024 into 1024 bytes. Then 1 megabyte, after that 1 gigabyte. 1 gigabyte means what? To the power 10, that is 1024 into 1024 into 1024 bytes. Okay. After the GB, TB means 1 terabyte. 1 terabyte equal to how many GB? To the power 10 GB, that is 1024 into 1024 into 1024 into 1024 bytes. Okay. This way it is calculated. from bit to byte and byte to KB, KB to MB. No? I'll show you again. Here, bit to byte, byte to KB, KB, KB to MB. After that, GB, then TB. KB means kilobyte, kilobyte, megabyte, gigabyte, and terabyte. How you can calculate it? This figure, no, it is given. Okay, so let us proceed. Next is RAM, random access memory. No, random access memory under the primary storage. No? So random access memory, which in short it is called RAM. RAM in figures, you see RAM figure 2.10 here, this is the RAM picture, okay, this is the RAM, which is fitted inside the CPU, where, here it is fitted inside this, okay. So RAM is named so because information stored on it can be accessed in any order, that is randomly it will store it. And RAM is a place in the computer that holds instructions for the computer, its program and the data. The CPU can directly access data from RAM almost immediately. It is also known as read/write memory, as information can be read from it and written onto it. So information stored in RAM may be written over or erased also. It can be written over and erased also. RAM is a volatile. It is called a volatile, which means that when the power supply is switched off or interrupted, the information stored in RAM is lost. So it is a volatile memory. Why it is called? Because, which means that the power supply, when it is switched off, no, or interrupted, no, that time the information stored in the RAM, it will be lost. RAM may be classified as dynamic or static also. A static means static RAM, SRAM it is called, retains stored information as long as the power supply is on. It may be static RAM, it will be retain all the information stored as long as the power supply is on at that time. Dynamic RAM, DRAM, which is called, slowly loses the stored information even when the power supply is on and has to be refreshed periodically. If it is SRAM, then it is good till your power supply is on, it will remain there, all the information will remain there. And DRAM, it will slowly it will be lost it. Okay. So to get it that, you need to be refreshed periodically. So RAM is randomly your data will access. That means your instruction, no, whatever instruction input you will give, that will correct to the RAM first, then immediately to randomly correct and randomly to send the instruction to the CPU. From there, from the storage unit, it will correct and it is volatile memory. It is called because when the power supply is switched off or interrupted, the information stored in the RAM is lost. Because of that, it is called volatile memory. Okay, let us see the next one. Next is ROM, read only memory. ROM is, this is the word ROM. Inside, no, the CPU, no, circuits are there. You can see the RAM, no, like this registers are there, which is called the ROM. Chips are there, no, it is called ROM. Like RAM, ROM is also a part of the built-in memory of a computer. However, unlike RAM, the storage of data and instruction in ROM is permanent until it is overwritten. It stores some basic instruction programmed by the manufacturer to operate the computer. The contents of a ROM remains intact even when the power supply is switched off. Hence, ROM is a non-volatile memory. So, ROM is what actually it is unlike RAM. Unlike RAM is what is like a RAM only, but unlike RAM, why it is called? Because RAM randomly it will be accessed and send it, and when it is switch off, it will lost. But unlike RAM, ROM, what happened? It is instruction of permanent, no, until it is overwrite, no, it is permanent, which has already instruction programmed by the manufacturer when the computers manufacturers to operate the what? To operate the computer. And because of that, the ROM is called non-volatile, because ROM remains intact even when the power supply is switched off. Because of that, it is called non-volatile. So volatile means when the storage randomly it can be accessed, and after switch off it is lost. That is called volatile. And non-volatile is ROM, which is remain after the switch of the power supply also. Instruction will be remain there. Okay. So RAM is random access memory. ROM is memory. Okay. So next is secondary memory. Under the secondary memory, the primary memory. Now storage unit two types. One is primary and secondary. In the primary memory, already we have discussed RAM and ROM. No, RAM and ROM already we have discussed. Next, in the secondary memory, we are going to discuss magnetic, like hard disk and all. No, those things, floppy disks and all. So in the secondary memory, auxiliary storage it is called. Since the computer main memory store data temporarily, the secondary memory is used for bulk storage of program data and other information. It has much larger capacity than the main memory. So the main memory is for what purpose? It is actually collect the instructions, the input and all, and that is randomly to sent to the computer. And for if you have a large amount of data, you need to be stored. Mainly for storing purpose, the secondary memory is used. Okay, so main memory is storing data temporarily. So bulk storage of program data, if you, other information if you want to store, then you need a secondary memory, which is hard disk and all. No? So it is larger capacity than the main memory. The secondary memory is non-volatile. Non-volatile means what? If you switch off the power supply also, it will remain there. That is, it does not lose the stored information even after the power supply is switched off. The secondary memory comprises the peripheral devices that are slower but much cheaper than internal memory. Okay. The secondary storage media can be broadly divided into two categories. One is called magnetic and optical. Okay. Magnetic and optical. So secondary memory is using to mainly to store your data and information permanently. A large amount of data you can store it. The primary memory to randomly to access it. Actually, RAM, read-only memory, random access memory, all these things. And the secondary memory is mainly to store the data in bulk. So secondary memory storage, media can be broadly divided into how many parts? Two parts. One is magnetic and optical. So magnetic media is what? Magnetic media is magnetic taps and discs are examples of magnetic taps and discs. Which is that? Magnetic taps can hold a large amount of data and are used to store information on large computer systems. Magnetic discs are either hard disks or floppy disks, depending on the flexibility of the material from which they are made. So magnetic media, magnetic taps, and hard disks and floppy disks, that is the secondary memory, magnetic media. This is the floppy disk. This is the one floppy disk, which is now explained already. People are now more using this. The hard disk already students know hard disk, about the hard disk. So hard disk, it looks like this. This is the hard disk. Okay, this is the hard disk, and inside hard disk looks like this. Okay, this is the hard disk. So inside this only all the information and data is stored. These are inside the hard disk. Okay. So in the magnetic media, hard disk or the floppy disk is using hard disk where we can store the data permanently. We can store the data permanently. Next is the floppy disk. You can see here the hard disk is given inside that, as I shown the picture. The floppy disks have become more less than absolute now. Absolute means now what is it? Now, a hard disk is made up of grid metals. A hard disk drive contains multiple disks known as platters, each with its own read oblique write head. These patterns are coated with the material that allows data to be recorded magnetically. So in the hard disk inside this, this is the metals, platters coated with what? Material that allows data to record magnetically. The platters, multiple disks with the platters it has made, and they can be recorded magnetically inside these platters. So floppy disks nowadays is no more using, obsolete now. Next is optical media. Optical media is compact disk, read-only memory, CD-ROM. Because the CD disks we have used now, CD-ROM. Digital versatile disk, DVD, you know already. And Blu-ray disks are the example of optical media. These are the ones. So in CD-ROM, let us see the pictures of CD, compact discs, DVD, Blu-ray. So this is the CD, compact disc, and this is the CD-ROM, read-only memory. This CD-ROM will read the CD. Okay, this is the CD, and this is DVD. Disk, and this is Blu-ray disc. Okay, these three types of optical media is there. Okay, so the compact disc CD-ROM, CD-ROM can store 700 MB of data, and that is permanently stored. If it is CDR means readable, recordable, again you can rewrite it. Okay, and in DVDs can hold up 6 times of more than the data of CD-ROM. That means 6 times of more than data of CD-ROM. Okay, it can be stored. And Blu-ray discs have the same dimensions only, but Blu-ray discs can store about how many GB? 25 GB. CD-ROM 700 MB and DVD 6 times of the CD-ROM of 700 MB. Okay, and Blu-ray 25 GB can store. Okay, optical media, these three are the optical media: CD, DVD, and Blu-ray disc. CD or CD-ROM can store 700 MB of data, and DVDs can store 6 times of more than the CD-ROMs or the series. Blu-ray disc 25 GB can store it. Okay, student. So let's proceed to the next. Next is flash drive and memory stick. Flash drive and memory stick. What is flash drive? When you heard about flash drive, it's like a new thing, but already you know about it. What is that? Flash drive is pen drive. You can say pen drive. Pen drive is called the flash drive. This is the flash drive. No? The flash drive is a small portable device that can be used to store, access, and transfer data. To transfer data to carry, as all of you already know about that. The pen drive is using to carry your data, information. Due to its small size, it is commonly called a pen drive, which is in figure here. This is called the pen drive. And we also called a USB also, USB drive also. We can read, write, copy, delete, and move data from one computer to another computer, with the help of the pen drives. So is many capacities are there, many different size of the flash drive or the pen drive, which is it has started with the 16 MB, 32 MB, 64 MB, 512 MB like that. Nowadays 1 GB, 8 GB, 16 GB, 32 GB, 64 GB, 128 GB pen drive also they are like that. It's popular, and it is actually it is popular. Why? Because easy to use and small enough to carry in your pocket. Because of that, using most of the USB flash drive, or pen drive is using most of the people, to carry the information along. It is carried to the USB port of a computer for what purpose? For reading and writing data, and the computer automatically detects this drive, and USB port is socketed on the computer, meant for connecting flash drive. Okay. So pen drive or the flash drive. So when I said the first time flash drive is like a new thing, but it's already you know about that. Pen drive. Pen drive is carrying for using for what was to carry the information and the data. No, small, that's why it is easy to carry also. Okay. So next is memory stick. You know already. No, this memory sticks, camera, no, camera. Those are using DSLR camera, digital camera. No, these memory sticks are using to store your photos. No, this is the one. So this is the one. Okay, this is the memory sticks. So a memory stick is using or card. No, memory stick or card is used for what? Storage media for a portable device like a mobile phone, can be easily detached and used in data access by a personal computer. No, digital cameras. No? Example is given. No, here you see the example is given. Digital cameras. No, you use the memory stick or the memory card for what purpose? To storing image files. Storing the image files. So the user can copy the pictures taken memory or the digital camera. No, can copy in the computer also later on after connecting the device. So, memory stick. This is the memory stick is using for what purpose? This memory stick is using for to store the images. Now in the mobile also, the mobile small memory card is using, and this memory stick is using the especially to store the pictures and all. Yeah, camera, digital camera, the DSLR camera. Okay, so proceed to the next. Next is smart cards and cache memory. What is smart cards and cache memory? Let us see that. Smart cards and cache memory. The smart cards are basically of two types. Memory card, which only contain a memory chip, and microprocessor card, which contains both memory and microprocessor components. So you see here, let me show you. This is the one. No, this is the one. No? The card where only the chip is there. No, that is called the smart cards. In the ATM card, you can see there. No, in the ATM card. Now it is driving license also chips is there. So which only contain what? A memory chip and microprocessor card is there. No, that is called the smart card. So microprocessor card allows one to add, delete and manipulate data on the card, whereas memory card can only perform the predefined operation. And smart cards are two types, two types memory cards and microprocessor. The memory cards here, this is the memory card, so smart card now. Some only the predefined information that can access it. No? And the microprocessor, if it is there, that you can what to do? You can add, delete and manipulate the data on the card. Okay. So smart cards also there are two types. One is memory card and another is memory chip and another is microprocessor cards. With the memory chip and microprocessor. Okay. Next is cache memory. Cache memory is what? It is very important. Cache memory inside the motherboard, in the CPU. No, inside the CPU, in the motherboard, you can see like this. This picture. Look at this, and in this picture, these chips are called the cache memory. What is the purpose of that cache memory? You are going to know now. Cache memory. Cache is a small memory that operates much faster than the primary memory. Just wait for a while. Okay. So cache memory is a small memory that operates much faster than the primary memory when the CPU requires a certain value stored in the primary. It first sends the request to the cache when stores recently used values. If the required value is already present in the cache, it is made available to the CPU very quickly because the cache memory is much faster than the primary. The cache memory is already pre-stored in the system, the motherboard. No, it is quite faster than the primary memory. That means RAM. And how it does work? When the CPU requires a certain value, stored in the primary memory, first it send the request to where? In the cache. The cache is so fast, no? It can be sent very quickly than the primary memory. So first we will send to the cache memory, and cache memory will store there, immediately it will be reply from there. Even a small cache that is able to store about 1% of data also stored in the primary memory can reduce the average memory access that significantly, thus improving the overall performance of the computer. Okay. Even a small percent, no 1% of data also can be stored by the cache memory, and from the cache memory only it is sent to the RAM, and the RAM will access it, and from RAM will access from where? From the secondary memory, and it will be give the output on the screen. Okay, so these are the one from the secondary memory. Today we have completed. From the secondary memory we have completed magnetic media, optical media, flash drive we have to complete, flash drive, then memory stick, smart cards, and cache memory, which is very important. It's faster than the primary memory. So today up to this, thank you very much. We will come on another day with some other topics we will discuss. Okay, thank you very much.